Hi, everyone. So I'm Simon. I'm in my mid-50s. I have a beard of varying quantity on my visage. It changes regularly, and it's gradually going grayer and grayer. And I am 6'1", or at least I used to be 6'1". I think old age is having some impact on my height as well, gradually as we go along. And I'm going to talk about something obviously a tiny bit different to maybe some of the other talks obviously that we've had today, but still related very much to sustainability. So, Soprano, sounding out the environment. Soprano is actually a project which has been funded by NERC as part of the Innovation in Environmental Monitoring, and we have a number of partners that we're working with that. It's a 3-year project, and it's the first project that I've been able to act as the lead on the project. So this is a new kind of thing that funding agencies are enabling non-academics to take on that particular role. So it's quite significant from my point of view. Now, I guess you need to set a little bit of context for Soprano. So Soprano is about biodiversity monitoring and how we use technology to enable that to happen in an automated way. But biodiversity, of course, is important. I think we all kind of have a feeling for the biodiversity being important, but it is recognized globally. It's part of the UN Sustainable Development Goals, and there is a specific global biodiversity framework that's been put together. Although it's non-legally binding for countries, there's a huge effort to both maintain, preserve, and enhance biodiversity. Biodiversity is part of the kind of natural services that we get, that the natural environment provides for us. And there are a number of aspects of that which are used in mitigating the impacts of climate change, which we're all increasingly aware of as each year goes by. So they include things like the natural environment acting as a carbon sink, aspects of things to do with biodiversity and the protection of agriculture and the growing of crops and foods through obviously things like insects and whatnot, maintaining flowers and whatnot. And also there's water regulation. So as we have more extreme weather events and more issues of extreme rain and that kind of thing, the natural environment, if it's able to operate in a way that it would like to be able to operate, and we don't go and change it, can actually mitigate some of those flood risks and those different aspects. So biodiversity, critical, important part of the sustainability story. So the key aims behind Soprano is to build an end-to-end system and an infrastructure that supports that to happen. It's about deploying intelligence at the edge of the network. So this is not about feeding data to a central system and having it processed there. It's about doing it at the edge of the network, and that comes with its own challenges. And it's also about delivering information in real time. And this is going to be trialed in a number of different scenarios in the course of the 3-year project. We're working with our main project partner, Forest Research, so we have access to some research forest sites in which the technology is being deployed. But we're also doing aquatic monitoring in there as well, and freshwater systems. And I guess the key thing about developing this system, from my point of view, is also that we build something that enables other people to contribute to both bringing intelligences in, bringing training data in, and actually being able to build and operate the hardware for the sensor devices themselves. Now, this picture is quite a busy looking picture, but it's meant to give you a bit of an oversight into the different elements that make up Soprano. So this is very much in terms of when the technology is deployed as the sensor devices into the environment. And the way that this is being put together is as a modular device. So it's not a single thing that you put into the environment. It's very important that some of the different elements of it are able to operate in slightly different locations in terms of the deployment. And that also enhances the sustainability aspect of it from the point of view of being able to repair individual components rather than deal with one single aspect of it at a time. But there's also multiple sensors being deployed here, not just the audio side of it, which is where the intelligence mainly comes in, but there's other environmental variables that we capture alongside the audio because it helps us to interpret the behavior that we're seeing. We've been interpreting what we get from the audio. The audio is mainly focused on identifying individual events or occurrence, instances of species being present based on the fact that they generate vocalizations and sounds. But we're also interested in calculating acoustic indices. So these are long-running, if you like, variables which measure what's happening in terms of the complexity of the soundscape, mainly. And different types of environments will have different kind of fingerprints in terms of that acoustic complexity that come out the other end. So you can see the variety of different types of events, and they include other types of events which are not coming directly from naturally, but created by us as human beings as well. Human activity in the natural environment has a big impact on what nature and the animal life will choose to do as well. So it's important to have that, and it's important to have the environment variables, because the weather obviously plays a significant role on the level of activity that the animals and the bird life, etc., choose to do. So there are some key aspects to the development of the soprano system, and some of which play very much into the sustainability story in terms of how we design and build a system and how we choose to implement things. The key from, I guess from the functional point of view, is that the automated ability to understand what's happening in the environment from this answers the question of scalability from the point of view of being very different to the kind of surveys that people will carry out and specialists will carry out, such as birding surveys and bat surveys and that kind of thing. But it's also because it's a real-time response. So there are increasing examples of invasive species and other types of events occurring naturally that we want to know about as soon as they happen, rather than discover that they've happened 3 months later because we've finally had a chance to recover our field recorder from a field somewhere and understand, oh my goodness, Asian hornets are present, which is too late by then to really do anything about it. And the key from the point of view of the biologists and the ecologists is to have that flexibility to understand and control what kind of monitoring is being carried out when. And it's also critical for us from the point of view of what we're deploying, because we're heavily constrained in terms of resources that are available for the compute, for data transfer and that kind of thing. So we have to deal with all of those kinds of issues as well. So really about smart energy management and also collecting energy, harvesting energy from the local environment, which at this point in time is mainly around using solar panels and battery storage and that kind of thing. But also in terms of data transmission, we are not needing any kind of high bandwidth transfer of data. We're not sending audio data anywhere in this. Audio data is being processed in situ. And we can then therefore make use, again, of much lower energy solutions for transferring the small amounts of data that we need to transfer on a regular basis. So we're using low power wide area network technology based on something called LoRaWAN, which has a very low energy aspect to it, but also very long range. So again, these are some of the choices that we make to minimize the amount of technology that we want to deploy into the environment to achieve our goal. Again, an aspect that's really important in the world of these types of classifiers and trying to understand the veracity and capability of these is having the ability to benchmark them and evaluate them and compare them with one another. So again, that's another aspect that's being built into the Soprano platform. And again, coming back to the modular design and the open hardware design aspect of it, we want to be able to make it possible for other people to fix these types of devices rather than have them be fundamentally replaced as single board entities or something like that, and also to enable a much more kind of low carbon aspect to fixing and keeping this type of technology going. So here's a diagram that kind of shows off different elements of the Soprano system. Over on the left-hand side, we've got basically the back-end side of it, which is all stuff that's actually running centrally in a data center somewhere. And on the right-hand side, we have the devices themselves. So the device is very much a modular design. There are different components to that, from communications to the actual audio, microphones themselves, and the environment monitoring, and then the Edge AI module, which actually processes the sound that comes into the system. And then the system administration, system management elements for keeping the whole lot going. And there's various different elements to the back end of the system. Obviously, the data has to be transmitted and collected somewhere, so we've got a data collection element to that in terms of the outputs from the models, in terms of what they determine as being present in the environment. We also have the models themselves, and they need to be built, and that's much more a kind of GPU-accelerated type exercise, and so that requires special hardware to do that, but that's really a data center type of operation. We've also got to manage the devices themselves. If there are a fleet of devices, there are a lot of operational aspects to keeping them going and understanding whether or not they're working and that kind of aspect to it. So that gives you a bit of an idea of all the different elements that are involved in building the Soprano system. And this is the first of the systems under the Soprano project, which was deployed in May at the Alice Holt Research Forest. So we've been collecting data from that. An element that I would point out is that we are placing microphones into publicly accessible spaces. And so we have to be very careful from a data protection point of view. And a big element of that is making sure that you've informed people who are coming into the space where these microphones are present. Now, the key thing about doing edge AI processing is, and in particular how we do it, is we don't record any audio. It's all processed in situ and transiently. So there's no risk to individuals in terms of us overhearing somebody saying something and having a recording of that that in any sense lives on. And it's not held within the device in any kind of permanent way either. So the key thing is that these messages have to be out there and people can access more information online about the system and how it works. I have a lot of experience deploying sensors into lots of different locations, and it's really important that you get that community that comes into contact with that aware of what that technology is all about, because people can very often misunderstand what that technology represents. And we've had all sorts of issues where individuals can get the wrong idea, and that increasingly seems to be the case in the context of them putting information out to social media, for example. So it's really important that you have your engagement strategy with your community right from the very off. So here is data that's coming in from these types of sensors. This is a particular presentation. It's identifying the amount of activity associated with a species, which has been detected on a daily basis. And this is based on the calls that they make and the recognition of that particular species. You can see that we're also picking up human activity as well. The models that we use have a wide range of capability of recognizing different types of things. So, I thought what might be fun to do is to see if anybody can work out what... I've got 3 little audio samples. I think you'll get the first one, so we'll just make sure that... I think this is going to work by if I press this button. So I'm pretty sure you'll all get the first one. Anybody not recognize what that is? So that's a cuckoo. It's a very distinct call in the environment. And I used to hear this a lot when I was a kid. I hardly hear it at all now. And it's on the red list. Cuckoo is one of the very endangered species, and that's why we're not hearing it very much. Next one. Here we go. This is a little bit more tricky. There you go. Does anybody have an idea of what that might be? Don't be shy. Put your hand up. Well, I have cheated slightly, so I do apologize. You wouldn't normally be able to hear that. That is actually a bat, and that is a pipistrelle bat. It's a soprano pipistrelle, and they're very high frequency, way above what we can hear. But what I've done is slowed that down so you can start to appreciate what they kind of sound like. So you were hearing a combination of basically those top notes as very sort of blip type notes. Is basically its sonar as it's looking and hunting for insects. That's what it does, is it sends out these blips and gets a reflection, and then it starts to zero in on the insect, and then you get that example with the much more louder one as it gets closer and closer, and it speeds up what it's doing. But they sound a bit like birds when they're slowed down, which is quite interesting because they're mammals and not dinosaurs, essentially. Now, here's the last one of the 3. to guess what that is? I can't see any hands up. Nobody want to take a guess? So that is, it's not a blue whale. No, it's not a blue whale. But it's quite a good guess for a good reason. That's actually an elephant. So that's what's called an elephant rumble. So elephants are really interesting because they generate infrasonic calls. So we can't hear them either because they're at the bottom end below 20 hertz. Because it's such a low frequency, it travels a very, very long distance. So elephants can detect each other's presence in the wild over spaces of hundreds of square kilometers as a result of doing that, particularly in places like the savannah where they've got the right kind of terrain for that to happen. So there you go. I thought that was kind of interesting. There you go. So again, to kind of visualize what that actually looks like, this is both bats and birds on here. The birds are all down here, and the bats are kind of basically all up there, including this part of their call. So I've got the wrong thing in my hand, but the key point that I was trying to make with this is there's a lot going on in the soundscape that we are not aware of. So this is where all the bat activity is, and below here is basically what we can hear. So it's probably a good job that we can't hear bats, because bats are extremely loud. And in fact, bats generate sound equivalent to a jet engine on an airplane. They are that loud. So they're way above 110, 120 decibels, some of them in terms of the amount of sound they can generate. But it's very high frequency, and it travels a much shorter distance as a result. So in terms of what we're able to detect with standard microphones, it's about 40 or 50 meter range for a bat. And essentially, when we're looking at what machine learning and different types of processing that people have been applying to this in the past, this is a fast Fourier transform, a spectrogram, and we're basically transforming an audio problem into almost like an image recognition problem. Again, I don't know if anybody wants to take a guess at what that spectrogram is representing as a species. You have heard it already. This is the cuckoo. It has a very distinct call, has a very distinct kind of look to it in terms of this, this representation. And this is what recognizers are basically processing. But to help those recognizers doing a lot of signal processing is definitely a good thing to do. So again, thinking about it from the sustainability point of view, a lot of people use cameras as well in the context of looking at wildlife. Why do I think microphones are a better bet? Mainly because they have such a wide range based on the amount of technology that you're deploying and the cost of the technology that you're deploying. They're not obscured in the same way that visual systems are. So they're cheaper. There's less kit that we have to deploy over an area. They consume less energy, and they're both less obtrusive and less intrusive. They're much, if you put cameras anywhere, and I have this experience from other projects, people get very upset. Public get very upset and think that they're under CCTV surveillance and those kinds of things. So microphones are a lot more acceptable from that point of view. So how do we kind of hook this back into sustainability at the University of Edinburgh? So the University of Edinburgh has a number of different schemes related to biodiversity and the natural environment. It has been investing in a forest and peatland program, so it's got nearly 900 hectares of land that's using for carbon offsetting. In the process of doing that, trying to set those environments up as good environments for wildlife. And we also have a wild campus initiative taking place as well. So the University of Edinburgh has about 5 distinct campuses in some sense, and some of them are to the south of the city, and they cover quite green areas. And you know, we're interested in what we can do to enhance wildlife on our estate. The key behind all of these kinds of initiatives, which also starts to tie into things like treating the natural environment as an investable place, so natural capital. This is starting to happen, and hopefully learning from the mistakes made from doing CO2, carbon offsetting. What's needed is an ability to verify what's actually being done in terms of natural capital investment and improving the natural environment. And that's where the monitoring aspect of it can come in. And having continuous monitoring is a key element of that. And we're talking to people as to how this monitoring can be used in that context to support investment in the natural environment. And that's all part of Smart Campus as well. So we're extending our definition of Smart Campus to cover those different aspects of what we're doing. And I promised I would give a Smart Campus update. So I gave a talk last year where we were talking about occupancy monitoring and Wi-Fi occupancy monitoring. Things have moved on quite a bit since then. We have a new network that's pretty much deployed now to more than 270 buildings that university owns and runs, and now includes student residences as well. So we've got some 60 plus halls of residence included in that. And the way that we use, this is purely based on the Wi-Fi processing, is we process people's connections onto the university network, which means we can do a number of things with that data. One is we know who you are, although when we process this data, you remain anonymous. By who you are, I mean the attributes that the university gives to you, such as, are you a student, are you a member of staff, and which school or college are you associated with. And that information gives us a lot of insight about how the estate is actually being used at any particular moment in time. On here, you can see a composite of a number of different types of graphs. At the top, we also provide an electric bike scheme to students. And so we understand how students are moving around. Again, this is completely anonymized. We don't know which route is associated with which bike. We don't even know which sensor is on which bike when we process this particular data. But it gives us an insight into how people travel around. And again, because we have multiple campuses, and they are some distance apart, which includes having to take buses and taxis and drive, cycle, etc. to get there, we have good insight into how the population is moving around between campus and campus, and that helps inform our travel policy and whether or not we need new bus services and that kind of thing. And you can also see that we have quite granular data about occupancy in buildings just from Wi-Fi alone, and we can understand when the buildings are occupied, when they're not occupied, when they're busy, when they're not busy. That information can be shared in a number of ways and used in a number of ways, and space management, space utilization is a hot topic. And now, working with the states, we're going to be developing this into a service that will be provided to lots of people across the university to access this data. There are some developments that will take place. We're going to start to combine Wi-Fi occupancy data with card access data. Card accesses are used to access some buildings and some areas of some buildings. In most cases, though, it's just card access on the way in and not card access on the way out. So it gives you a limited view of what's going on, but it's important to help understand how accurate the Wi-Fi data. So the combination of the two data sets is going to be very useful from that point of view. Our experience to date in most buildings, and it does depend on the particular building and the, if you like, the subpopulation of people and their behaviors associated with that building, is we get to within about 5 to 10% of accurate occupancy levels in the building based purely on Wi-Fi alone. And I just wanted to finish up where I started, which was to point out that I'm now project lead for a research project, and I'm not an academic. So it's now possible for you to do these things. UKRI offer all sorts of funding opportunities through the different programs that they operate. The Soprano one is under the NERC funding and under the Innovation and Environmental Monitoring Program. And because I have an equivalence between to an academic under this technician equivalence arrangement, I've been able to become project lead on this particular research project. So it pays for 30% of my time. Yeah, it's a good thing to do. It's a very enjoyable situation to find my in. There's quite a lot of red tape and things involved in making this work, particularly in departments which have never had a research grant before, but I'm sure that's the case in many institutions. Yeah, so I just wanted to finish on that, really. Thank you. So I'm happy to answer questions about biodiversity monitoring or smart campus.
Jim, I've got a question. Simon, just wondering, the Soprano system you have been developing, can you see any other uses for it beyond biodiversity? I can't even say it. Biodiversity monitoring.
Yeah, certainly, and we are in discussions about how this technology would be used in other contexts as well. So one in particular that we're talking about at the moment is the use in healthcare. So again, the same infrastructure, the same mechanisms that we set up, it's really just a different audio classification problem that you're solving. So in that case, what you're interested in is understanding the behavior of an individual living at home under an independent living arrangement and wanting to understand how their behavior, has their behavior changed over time, because that's an indicator of a potential intervention. So that's one particular example. Perhaps tying it back a little bit more to Soprano, we've been looking into doing a project with the Hutton Institute on doing soil acoustic monitoring. So that's understanding what's actually happening in the soil based on the sounds of various things going on in the soil, not just earthworms moving around, but it includes those kinds of things. So that's another interesting challenge in terms of actually getting reasonable data in.
Thanks.
There's a hand up at the back. Oh, hand up here, sorry. And one at the back.
Thanks so much for that. Just some crossover in terms of different natural habitats that are the students. It'd be interesting to hear how high-pitched the shrieks get when the Wi-Fi is down for some of the students in the halls of residence, or how low the yawns are for the lectures at
another
9 in the
application
morning.
of audio monitoring is, yes, to understand when there's screams going on of, not delight necessarily, but anguish. I defer you to Tony to answer that question. But yeah, absolutely. Noise pollution is another application, actually.
I apologize if you covered this in your presentation, but I was wondering how you were parsing the audio data. Because I'd imagine if you have a microphone, you're just taking in all the data all the time, 24/7. So are you running some kind of edge computing model on the device to split that data up, identify the species that you're looking for, and then send that data to somewhere to be analyzed?
Exactly. It's exactly the solution that happens on the device. There's quite a lot of things that you can do at the signal processing level before you feed audio onto a particular model. And in particular, you want to do that because models are quite expensive to execute. Again, we're highly resource constrained at the edge of the network. We don't have a lot of power to play with, so we want to use that power to greatest effect. So there are things that we can do to process the audio beforehand, before it gets there. In terms of how it works at the moment, we split the audio up into 3-second components, and that's sufficient to capture the main distinctive aspects of all the species that we're currently interested in. That may change with other things, and there are other things that will happen with the physical technology and the microphones, which will enhance our ability to be processing what's coming in. So in the future, we'll be able to determine not just that a species is present, but we'll be able to understand how many individual species are present. And eventually, the technology will develop to the state where you'll be able to understand that the same individual has come back. Where the individual has a distinctive call, you'll be able to track that particular individual moving around the environment. But we'll be able to know how far away something is from the microphone and which direction it's coming from. Another hand up.
Any wisdom you can offer about being a PI or a co-I on a project as a sort of more technically minded person? There might possibly be some reason for me asking that. But
Yes, I mean, I'm very lucky because I work with great people. I mean, I've obviously formed relationships over a period of time with certain academics in the university, and you get to know which ones that you can work with, if you like. So I'm working with a guy called Mark Naylor, and he's absolutely brilliant. He's in geosciences. He's really into the whole kind of aquatic monitoring and river bedload movement, which doesn't sound necessarily that exciting, perhaps, I don't know, but is actually a critical element of understanding the ecosystem around the river and the impacts on both the river system as well as the life that actually lives in the river as well. But yes, you need to be well compatible with your co-Is in order to have a successful project. I have worked with other academics in the past where I would say that wasn't the case, and interestingly, those proposals weren't even successful. They didn't get funded. So, so yes, pick your co-I wisely, certainly. Can't see another hand up. There we go.
Thank you.